Hello, you guys hear me? Yes. Well, first of all, thank you, Pedro and Alexander, for inviting me here for the keynote. My talk is short-lived clouds, and hopefully, I will convince you at the end of the talk that the future cloud, right, is based on ephemeral functions, and we should build all the cloud services around it. Before presenting the content, I will quickly just run very quickly into my bio. So I did my PhD at the PFL. Basically, I was there at the intersection of cloud and systems and computer architecture, and then I joined Huawei R&D. I'm located in Munich, yeah. So now I'm running one of the teams of R&D teams in Huawei Cloud, yeah. So I will be here for the entire conference. So if you guys want to just chat, catch up, and we can discuss more in more detail what we're working on, and we'll be very happy to discuss with you. Very quickly, because probably nobody here has heard Huawei Cloud before. So we'll maybe just give a little, a very quick summary. Huawei is also a public cloud like AWS and Azure, and we are actually second in the Chinese market, and we are fifth infrastructure as service in the global market, and we have many regions. So again, if you are interested, we're actually now also expanding in Europe. So in any case, if you maybe for research, if you're interested in maybe some credits or anything that you think might be interesting for you, just approach me. Again, I will be here for the entire conference. And actually, we have the entire stack. We are a very vertical company. We build our own CPUs, GPUs. We have our own AI frameworks, serverless computing, storage service, computing service, anything that any other hyperscaler has. So we actually recently started also building our own GPUs. So and actually, we are one of the few providers that also provide GPU functions. So you can actually run functions on heterogeneous hardware. So I will actually present this before. I know that AWS doesn't have it, but Huawei has it, and Alibaba Cloud also has it. So hopefully, we will see this more in the future. Anyway, so this just a quick intro. Okay, so I think first, before motivating serverless computing, I think we have to motivate cloud, right? Why do we need cloud? So I think really sort of the epitome example that I always give when someone tells me, oh, why do I need cloud? It's about the example of Pokemon Go. So you guys know back in 2016, right, that this game was all over the place. So the thing is that this is a little slide from a post from Google, right? There were a bunch of solutions architects from Google that they were helping the company to basically move to the cloud. And basically, you can clearly see here that they had some initial projections about, if you actually look at the x-axis, you see basically the time, right? And if you actually look at the y-axis, this is the load, right? And the expectations, right? You see basically the traffic of the basic what they had at launch, and also actually what they estimated as to be the worst case that will be several factors away from that, almost 100 magnitude more. But you actually see that the actual traffic was just completely exponential. I mean, it really completely went off rails, and you cannot sort of buy blades fast enough, right? You can install them fast enough. You cannot build your cloud fast enough, and that is really why you actually need the cloud, right? Because in cases where your load just increases so dramatically, or actually when you really don't know what your load is going to be, this is when cloud computing is really the answer. And to be honest, I mean, there are many examples, right, in which these same scenarios happen, and that's why we need the cloud. Now, when it comes to serverless computing, right? So there is this interesting paper a few years ago, and I think that they motivate this really nicely, and they make the analogy with today's world, right? So the example of why do I need serverless computing? Basically, a very interesting example is in the paper that they depicted here, is that basically, let's say that you land at the airport. So let's say that you want to go somewhere. So you have two options. Of course, you can essentially rent your own car, and of course you have different sort of versions. So you have maybe an SUV, you have maybe like a Mini Cooper, right? You have different, of course, associated costs to it, but essentially you have to take care of you have to drive it, you have to basically return it, you have to be paying some flat rate probably per hour or even per day, right? So basically that's basically the traditional analogy of what cloud computer would look like. But if you go to serverless computing, the analogy will be essentially if I just call an Uber, right? I mean, you don't care about driving it, you don't care about maintaining the car, you don't care about anything, right? You don't have care about putting gasoline. So basically, you are just paying for that particular ride, and you forget about anything else, right? So this is the same analogy of serverless computing, that essentially you don't care about the maintenance of this infrastructure. It's simply that you are going to whatever functionality you need. You just write that. The cloud takes care of everything else, and this is basically the same analogy here. Now, what are the implications, of course, between these two models, right? I think the what customers see is cost. It's all about cost, right? They don't care about anything else. It's always cost. The thing is that if you look at the two models, right, what are you actually really paying for, right? So if you actually look into this figure, if you look at the x-axis, you will see essentially, time, as your your user logic is executing, but depending on your what is your abstraction in the cloud, of course, you can go to the on-premise servers, right, which is a white and flat line. That is, you have your infrastructure, and that, you paid some cost and you have it there and it's fixed. Now, if you actually look into the systems like, virtual machine abstraction, you essentially, you have to boot the machine, take some time. Also, when you kill it, it also takes some time to get killed and to allocate it. And essentially, this translates in that you are actually really paying for a lot of associated costs that are not really the execution of what your user logic needs, right? And if I'm looking into serverless computing, you are essentially just, even if your system is idle, right, you will not pay for it, right? When you get the machine, because as I said before, we are renting it for a particular time, maybe an hour, then you are going to pay for that. You have reserved it, so you pay for that whether you use it or not. And with serverless computing, you essentially you just pay when your user logic is running. In this case, in the function abstraction. Now, the question is, how much do you pay for it, right? So if you actually normalize both with the same time frame, actually you see that, yeah, serverless computing is more expensive, right? If you actually compare given the same timeline, and it's the same analogy that I made before, right? If you actually are driving, call an Uber for a day, right? Driving around, it will be super expensive compared to when you actually go to and rent a car that maybe is a fixed cost per day, and it's at the end of the day will be cheaper, right? So the thing is that there is a clear trade-off there that we actually have to play with, and the thing is that, yes, you only pay for what you use, right? But the cost is significantly higher, right? So the question is, you have to try to exploit the basically what's good about serverless and try to mitigate what's bad about serverless, right? Now, when you essentially you look into the basically the structure of the talk, right? I'm going to try to indicate basically what are the good things, the bad things, and the ugly things about serverless computing, and I'm going to talk about this vision, right, that we have ideally in mind of a short-lived cloud, right? A cloud that is just built out of ephemeral functions. And this is 2023, so they cannot be a talk without LLMs and ChatGPT. So I'm going to try to basically, what does this mean for serverless computing, right? And I saw some interesting basically sentences there about serverless GPT and those things. So I want to try to also bring those two words together. And finally, I will conclude. Now, what is the good, the bad, and the ugly, right? So what is the good? Zero provisioning. This is great. If I don't need to deploy anything, I don't pay for it. It has auto scaling and it has relatively faster startup times than the other abstractions. It also has fine grain pricing and resource allocation. That means that, you are, for the provider, the packing problem is much simpler because you have finer granularity. And for the user, it's also good because actually you have this auto scaling, so the user does not have to care about all this logic that is actually very costly when it comes to deploying. The bad is that you have limited execution time. You have lack of this communication among lambdas, which is basic one of, I think, one of the main problems that the community tries to solve. You also have fixed memory to compute ratios. And so far we have seen that most of serverless computing is restricted to CPUs. And the ugly is that, I think this is really the ugly, that you really have no control of execution at the deployment. The user has nothing, no control about that. And this is something that can be really, really, really harmful. So the question is, what are the implications to the real world? So, I mean, the end result is that we have seen a lot of serverless computing that has been tailored to simple applications and flows that are really, 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 really simple, right? There's a gateway, there's a few lambdas here and there, and then there's results, right? And this goes for, you can see the solutions architects websites, and there is a lot of about doing things with the blobs in S3, or also there are some architects that are saying, oh, why don't we have a web application and we can map it into serverless because the traffic is not that, that constant. And, this is more or less what you have seen, right? But at the end of the day, this is a bit of a niche, right? Ideally, there is so many applications that are so important, right? Analytics, streaming, databases, all AI. So all those things that, it's really, this limitation, it seems that they're precluding their use of serverless computing for them as well. So, the question is that what are out of these limitations that I presented before are really fundamental, that they cannot be fixed. So if you actually look at, the limited execution time, this is just some arbitrary number, right? There's nothing fundamental with it, right? So if you actually look into, even at the beginning, right, AWS Lambda supported 5 minutes of execution. Now it's 15 minutes, right? I mean, they can change it. And in fact, I'm 100% sure that the internal teams of AWS and Azure, for themselves, they can avoid this limitation. For example, we can use in Huawei Cloud, we have function graph that is AWS Lambda, and if we have an internal account, we can remove this limitation, right? So there's nothing fundamentally. There's nothing fundamental with this problem, right? So again, this is simply some number that they picked. The other thing is lambda-to-lambda communication. Although this a priori seems tricky, and indeed it is, there's actually work that has shown that actually you can go around it, right? That there is this paper about using not punching, and then there is an ongoing work from the University of Edinburgh about basically extending the control plane of Knative with these payloads. It's called XDD, and it's now an archive, and you can see that you can get around it. So technically, I mean, at the end of the day, we're just trying to send RPCs from one function to another. Technically, there is nothing inherently limiting here. About the fixed memory to compute ratios, I mean, essentially, these are also not essentially limited, right? Because this, again, some ratio that the provider gives you, right? So if you actually go to AWS website, you see that the amount of memory that you have dictates the vCPUs that you have assigned to your function. But again, this is something that AWS, for example, decided, right? This is something that Huawei decided. But technically, there is nothing fundamentally for exposing more variability to the user. And in fact, there is this paper recently in Eurosys that actually showed that if you indeed have access to completely say, hey, I want X vCPUs and Y gigabytes of memory, you can actually do much better, right? So this is simply an arbitrary decision of the provider. When we actually restricted to off-the-shelf CPUs, this is the thing that I brought this before. This is not true, right? For example, if we actually look, and it's not fundamental, if we actually look at the AWS Lambda, now they also run in Graviton, so it's not that you can just write on round lambdas in off-the-shelf CPUs, but also we can now GPU functions from Alibaba Cloud and Huawei Cloud. So, you want to write your little CUDA code snippet and run it as a function, hey, you can do it, right? So again, there is nothing fundamental, right? We can definitely do it, right? It's nothing that it's really nothing that per se we cannot do. And the ugly. So the thing is that this is really, really, really something that I think that is really fundamental because it's a contract between the user and the provider. So essentially, we have wasn't the talk like 40 minutes? You can extend by 10 minutes. Okay, because I thought the talk was, okay, it's okay. I thought the talk was going to be longer. Anyways, I'll try to go fast. Basically, essentially this is a contract, right? So if you actually look at the serve pool, you know, the VMs are a black box from for the provider, right? So when you get a VPC and you get a bunch of VMs, imagine that I have as a driver Spark here. The provider doesn't know anything, doesn't know how to schedule things. You know, this knowledge is not there, right? This is completely a black box. But in the case of serverless, it's something interesting because the VMs are a white box, right? You know, the platform as a service is the one that's controlling all these things. What is a black box are the function. The function logic is a black box. So the question is, you know, we are going to have lack of control, of course, because the user cannot know how to schedule these things because now is due to the infrastructure and the functional service, right? So, and that can lead to a lot of problems, lack of locality. How can I overlap computation with communication across functions? Very hard, right? So this is a fundamental, but can I take it to my advantage, right? Can I flip it somehow? Okay, so just to recap, I've shown what are the good, the bad, and the ugly, and I'm going to show essentially how these are not fundamental and how we are going to bypass them and how to turn the ugly into actually something positive. So my vision is short-lived clouds that essentially instead of just mapping a fast to, you know, simple applications like wake ups, we actually map absolutely everything, right? And the thing is that if someone comes to me and tells me, oh, Javier, but, you know, database and analytics are already serverless. No, they're fake serverless. They're just deployed by the cloud provider. It's nothing serverless. The software stack is the same. When someone says, I have Spark serverless, no, it's not serverless native, right? They just is the same software stack, the same cluster, just deployed by the provider, right? So this is, you know, we have to envision these short-lived clouds, and basically, I'm going to hopefully motivate you how to achieve this. Now, so to recap, I'm going to exploit the benefits of serverless computing because I think this is not done today. I'm going to show you how to mitigate these limitations, and then I'm going to show you how to turn the lack of control on the user side into something positive. Now, really, when you go to serverless computing, really exploit auto scaling. So I have seen these papers, you know, Lambada, Starling, the one after that, you know, from EPFL that they map SQL into fast. They always compare, you know, they fix the cluster in terms of memory size of workers, and they compare with the provision one. And the thing is that I understand because it is apples to apples comparison in a sense, but you are not exploiting the capabilities of serverless computing because technically with serverless computing, every single query, you can define the deployment, right? And you can optimize it based on the cost and time or make it Pareto optimal curve. I will give you an example. Imagine that I have Spark here. You know, when I run the query, I have 4 CUs, and these are the 4 CUs that I'm going to use to run the query. Okay, and that's it. This will take minutes to upscale and downscale. No one does that. I have a cluster, and I execute the query without resources. With SQL and Fast, literally, I can really say, okay, I'm going to run in one function, I'm going to run in 2, or I'm going to run in 32. And this is something that we need to exploit, right? Tailor the deployment to the query and the data set. And I can do that because I can define the number of functions and I can define the memory size per function. And, you know, this is, you know, don't be shy, visit the entire Pareto frontier. Now, about making the timeout resilient. Okay, I've said that this is not fundamental, but we have to get around it, right? So basically what we have seen is that there are data plane functions that actually could have a huge state, and there are control plane functions that, you know, the state is small. But we have seen that because there is 15 minutes of granularity between the timeout, we have seen that generally the solution of checkpoint in the user state and then taking the next function to take the load the state and run tends to work well. I mean, perhaps it will not work 100% for all the cases, but so far, we have seen that for analytics, data frames, it's okay, good enough. Like, for example, we see this could be a problem when you have data plane functions like pipeline breakers that really have a lot of state that you keep in memory, and this will take time, but because, you know, granularity is relatively big, it's usually not that of important. Another thing is, you said, okay, we cannot efficiently communicate with functions. So we have to try to create locality. There is a lot of, you know, when you actually go deep down in the algorithms and in the logic of databases, you see that we can actually, we have a lot of opportunities to actually create locality. And I won't go in detail to all of this, but there is a lot of, you know, operator fusion, horizontal, vertical, And this, long story short, what you are trying to do is that because you know the query and you know the data sets, what you're going to try to do is that you're going to try to create locality to actually avoid basically communicating between lambdas. And this is something that we have to exploit. And it was not, I mean, you will tell me, is it possible with provision services? Yes, but it will not be as useful because when you are in a provision service, you already have the resources. You cannot tailor the plan and the data sets that are flowing because you have to execute the query with what you have. So you cannot exploit this that well. Another thing is that the most important, how to say, the most important, I will say, effect of serverless computing is that it's forcing us to decompose our software stacks. So if you actually look at that software stacks or a complex analytics engine, we actually were forced to start peeling out the traditional data management systems and, you know, parsing, binding, optimizing, distributing doing the distributed query optimization, the query engine itself. And this is, I think, one of the huge benefits of serverless computing. And look, if tomorrow someone changes the platform, doesn't matter because we already decomposed the software stack and it allowed us to make everything very elastic. And you will see that elasticity is a requirement. You will see a lot of, you know, applications that are very important that you may run for a few seconds or you may run for a week. So this is something that is very important. And another thing is that we should exploit heterogeneity because, as I said before, the fact that now we support GPU functions really allows us to look into prior work on executing ML on serverless computing much better. And the last thing that I'm going to present that I think is very important is essentially, you know, we should expose the workflow abstraction to the provider. What does this mean? Is that, look, in the past, in infrastructure as a service, I don't know what the driver, what the master of these applications inside the VMs were doing. Now, if I'm able to expose this workflow as a first-class citizen to the cloud provider, the cloud provider can do everything, can collocate functions next to each other, can understand computation with communication, can all the things that before we were not able to do. Now we can do it, and I think really we should now. The workflow abstraction has to be a native part of the functional service and also the cloud infrastructure. And this is something that it will turn our downside of not being able to control where things are deployed and run into an advantage because really now we can see the dependency between worker nodes. Before, in infrastructure as a service, we couldn't. We have VM, look, if a driver of Spark is mapped inside a VM, I don't know nothing about it, right? And okay, this is basically how to, you know, the recipe to achieve short-lived clouds. And again, the last few slides very quickly about AI-centric clouds. Okay, so as you guys know, everything is going to the memory, okay? And you guys know this very famous quote from the Richard Side, from the architect of DecAlpha. And essentially, you know, everything is now built around memory, is becoming very expensive, and the models are really dwarfing the memory capacity because it's not scaling. So the thing is that our clouds is becoming a sort of supercomputer cluster. So I think the question is, in this era, when we have this new cache hierarchy, how do we build now our serverless computing? And if you actually look at the data centers, right? The data center traditionally from I don't know, from the 2020s, now you see that now we are looking into global memory access with CXL technologies, with disaggregations. So the question is, how do we build a fast platform around it? I saw some very interesting comments in the you know, names of investment technologies, and I think it is very interesting, right? How we build a platform around it. It's food for thought, and I think we don't know how to do it. All right, and this is a recap of what I explained, and I will conclude because I'm running out of time. And again, this is a research team, so I don't do these things alone. And please, if you have any questions and you're interested, just come and talk to me. Yeah, very good. Thank you.
Yeah, hi, thank you very much for your talk. So I think one of the main advantages of serverless is also that it's very easy to use, that you don't have to have a lot of experience in writing applications, and you just write a little bit of code and you get a very scalable application that can basically scale up to infinity. And I think a lot of the disadvantages you just mentioned in your talk are actually there to make it very easy to write those applications. And if I understand you correctly, you want to expose some of those complexities to the users again so that they can configure them. But doesn't that make it harder to use those platforms because you have to have a lot of experience in distributed systems to be able to configure all of those things?
Okay, thank you for the talk. Yes and no. As always, I would like to strike a balance. So I think that if you look at all the things that I was mentioned before, I don't think there is not inherently complexity that you add here with respect to the baseline. The only part that it has more complexity is the one that I was related, it was talking about fixed memory to compute ratios. Because this, for sure, yes, you will start basically exposing you will let the user, right, to sort of say, hey, give me this vCPU and give me this memory. So in that, I think this is because but the other ones, again, are still there. It's just that there is some arbitrarily picked number and you cannot sort of change it. And the workflow, I mean, even if you are imagine, right, the Spark system architect, let's put it this way, you know, there is a DAG, right? There is all those things will be written from an expert. You don't have to play with it, right? So about the memory to compute ratios, I mean, my opinion, to be honest, is that you can, of course, let the user play with it. At least make it the mechanism available. You can, of course, if the user doesn't want, you can provide, like AWS is doing, provide a fixed ratio. If you want, I think that's perfectly okay. But for an expert, for systems people, let the people figure out what is the right thing to do. And because I think at the end of the day, when we say user, many users are just sort of users of this thing, right? What you care about is that the systems builders, right, are able to sort of build the system around it. So long story short, I think we can strike a compromise and a balance between the two.
Any other questions? If not, let's thank our keynote speaker.
Thank you.